So this is my smart clock, built using a Waveshare 4.2-inch monochrome RLCD display. It's got 4 different display pages, and you can cycle through all of them using this single button located on top. Super simple, no touchscreens or anything fancy, just clean and functional. Each page shows something different, from time and weather, to bus timings, to even AI voice prompts. The programming is somewhat tailored more for Singapore's context, especially for the display parameters such as time, weather, PM 2.5, as well as bus arrival timings. Alright, so this is the main home screen. Front and center, you've got the current time and date, synced over the internet, so it's always accurate for Singapore. Below that, there's local weather info, temperature, humidity, and even PM 2.5 readings, so you get a quick idea of the air quality. The temperature and humidity are actually pulled from a weather station at a town in Singapore, so it's based on real, nearby data, not just some generic forecast. Charging is convenient with using common USB-C power source. Each full charge do last about 12 hours on my setup. However, I do tend to leave it connected to a power source most of the time. Next up, this page is for bus timings. I've set it to show 2 bus stops, along with their IDs and names. And for each one, you can see the next 2 arriving buses and their estimated arrival times. The data comes straight from LTA DataMall, so it's basically as accurate as the official app. It's really handy if you just want a quick glance before heading out. Here I am doing a quick sanity check at Bangkok MRT Station Exit A bus stop. While noting that bus 114 had passed by already, the next buses to anticipate are buses 102 and 27. Video fast-forwarded here by 6 times. Here we see the buses arrived on time. Note the accuracy is dependent totally on LTA DataMall and has nothing to do with the device itself, which simply pulls the data every 1 minute. I was also using my phone as a mobile hotspot. The next page here brings some fun. It cycles between random online trivia and custom images every few seconds. The cool part is, you can actually load your own images onto the display, but they need to be converted into a 2-bit monochrome format first. I've included some Python scripts on my GitHub to not just handle that conversion, but also create desktop JPEG previews, so you can pretty much preview and display whatever you want. The last page is also probably the most interesting page, being an AI voice query interface. There's a built-in microphone, and once it detects sound above a certain level, it starts recording for up to 6 seconds. That audio gets converted into text using a speech-to-text model, and then it's sent to the GPT model to generate a response. So you can basically ask it quick questions, and it'll reply, all within a few seconds. Here I made queries regarding places of interest in Singapore and France. I also made an inquiry in Chinese Mandarin regarding the distance between the Earth and our Sun in the solar system. It did well. The text-to-speech model from OpenAI can handle multiple languages well, such as Spanish, French, German, Portuguese, Italian, Japanese, Korean, and so on, along with English and Chinese Mandarin. Do note that to use this API, it does require an OpenAI API key along with a small charge. So far, it cost me 6 cents in a month or so, from triggering few hundreds of queries during the trials. Pressing the top left button will bring us back to the first page again. A long press on the middle button will bring it to standby mode, as we can see now. And with a double pressing, the device will resume its function again. It may take a few seconds for the device to reconnect to Wi-Fi again. The button on the right is to enter firmware bootloader mode, in which the use case is unlikely. The build is based on ESP32-S3 RLCD 4.2, which is a monochrome RLCD development board based on ESP32-S3, supporting Wi-Fi and BLE dual-mode communication. This display is 400 pixels by 300 pixels without backlight and display especially well in bright sunlight conditions. As with all ESP32-S3 devices, ESP-NOW protocol is also possible. This 4.2-inch RLCD has low power consumption, e-paper-like display experience, and faster refresh response. This device comes integrated with audio codec circuit, dual microphones, speaker, SHTC3 high-precision temperature and humidity sensor, TF card slot, RTC header, and lithium bat charging and discharging management circuit, etc. However, in my use case here, I am not utilizing the speaker, temperature, and humidity sensor for now. Reserved USB, UART, I2C, and multiple GPIO interfaces are located at the back for easy expansion. Connect a data-capable USB-C cable from PC to this RLCD. Note the port it was connected to and set the corresponding settings in Arduino IDE accordingly. In this particular case for me, it was COM port 8. Clone the whole package from GitHub link provided and open the INO file from Arduino IDE. Make sure the correct board is selected under Tools, and in this case it would be the ESP32-S3 dev module. Please also check through the settings found under Tools, and each of them should match up exactly as shown. Once ready, compile and upload the package into the device. Feel free to customize the code and package to your own needs, including those of custom monochrome images as H files, mentioned earlier. Some of the image H files were already converted from using the Python script provided in the GitHub link below. For the very first compilation and upload, it may take a few minutes. One will know if the upload was successful if the connecting to Wi-Fi screen shows up. If the version of the package uses the external SD card for config, simply go to the config template provided and edit to your own configuration including that of SSID, passwords, your own LTA DataMall API key, and also your own OpenAI API key. Make the bus arrival reporting relevant for you by also getting bus stop ID as well as the bus stop names. Data from 2 bus stops can be loaded simultaneously. Once ready, save this config with your data into an empty, FAT32 formatted SD card. Take note that the file name and the header names must not be changed. Load the SD card into the device and wait a moment. The clock screen should load after retrieving the NTP clock data from a server. This means that while the same code can be loaded across devices, the SD card slot allows flexibility for different users to load in their own personal configuration by means of editing a config file in the SD card. The personal data such as Wi-Fi SSID and password need not be hard-coded into the firmware. This brings about conveniences because the device can be passed around and reused by anyone without the need to reprogram the device. I have designed simple 3-part components using on-shape CAD to assemble with the RLCD. The 3D prints are done from JLC 3DP using stereolithography 3D printing. It takes about 1 week to deliver upon loading the order, including the shipping time from China to Singapore. More information such as dimensions as well as material used may be found at the WordPress link below. The buttons are deliberately designed to have 9 pieces in each build, since we need 3 per device and we will have 6 bays in case of damage or losses. In any case, the cost is the same regardless of 3 or 9 pieces. Use a cutter to dice out the buttons. Place the buttons into the front cover and then load in the RLCD. Note to orient the RLCD such that the USB and SD card slot lines up with the front cover opening, as shown. Ensure that the 3 buttons are located in place before putting on the rear cover. The rear cover will mate to the front cover by having 2 cantilever snap fit joints. No screws will be needed at all. Super simple. Furthermore, the cantilever joints also has an added mechanical function by acting as stopper to keep the face of the RLCD in flush to the front cover opening. After initial assembly, do connect a USB-C charging cable as well as a SD card to the device for a fitting check. There are many variants of USB-C cable in the market, but most should be able to fit. At the assembly level, the only complaint I may have is that the flatness of the rear cover may be slightly off at the corner edges, but it takes a very observant person to notice them. Overall, I am quite satisfied with the 3D prints from JLC 3DP. The acrylic leg stands do come with the original RLCD delivery and can be reused again to tilt this clock by about 30 degrees from vertical. This is an overall screwless design. Everything just fits together nicely. Keeps the build clean and pretty minimal. To open the enclosure again, it is also very easy with just a flat head screwdriver to disengage the snap-fit cantilever. Just take note to ensure that the USB-C cable and SD card were all removed prior to doing so. There are a few motivation factors for me to build this. As my children grow, I want them to keep track of time better. We had some cheap desktop clock prior that has to be readjusted time to time due to either battery running out without RTC or out of sync by a few minutes over time, or all of it together. This smart clock now allows my children to keep track of time better because it is always synchronized to the internet time. My family can be more aware now of the ongoing air quality, general weather, temperature, and humidity before heading out for the day. The LTA DataMall bus arrival API allows my family to plan better before going out the house and minimize the waiting time at the bus stops. The trivia page as well as the ChatGPT page allows my children to remain engaged and hopefully help them trigger new thought processes and satisfy their hunger for knowledge. In my opinion, this is somewhat useful for parents who are delaying the access of smartphones to their children. I have left some affiliated links below to procure the RLCD, as well as also GitHub link to help get you started. But take note that the firmware functions are designed mainly for Singapore's context. Step files for the enclosures are also available in the GitHub link below. It's made up of just 3 3D printed parts: the front cover, the back cover, and the 3 buttons. The acrylic leg stands do come with the original RLCD delivery and are optional additions to tilt this clock by about 30 degrees from vertical. No screws at all. Everything just fits together nicely. Keeps the build clean and pretty minimal. Overall, to recap, this is a monochrome RLCD based on ESP32-S3 that you can easily customize and repurpose the firmware to your own needs. In my case, I am using it as a synchronized clock, as a monitoring device for bus arrival times, for loading trivia, as well as for my children to use it as a convenient voice-activated Q&A with ChatGPT. I hope you will find it useful and also explore some other use cases as well. Thanks for watching, and happy building!